In this episode of Blender Bitstream, we're breaking down a reliable workflow for baking your own curvature maps in Blender, producing results comparable to Substance Painter. You'll need a baked normal map and ambient occlusion map from a high poly model for this technique. I've already baked the normal map and AO for this object, so I've got everything I need to build the curvature map. I'll switch over to the material editor so I can start building the shader. First I'll make a new material and name it, and then I'll assign the material to all of the low poly objects with Ctrl L and linked materials. Now I can add my normal bake image and I'll use its data compared with geometry normal to build the foundation of my curvature map. I'll start by plugging the normal bake image into the color input of the normal map node. Next I'll add a geometry normal node and plug it into a vector subtract node along with the normal bake. This removes the bake detail from the geometry normal so I can isolate the curvature. Now I'll add a vector length node and plug the subtract node into it. The length converts that difference into a black and white value that represents the curvature. Next I'll add a color ramp, set the left color stop to 0.59 and the right to 0.6 and plug the vector length node into it. I'll then add a subtract color node and plug the color ramp from the vector length into the A slot. To make the curvature map a little more gritty and realistic, I'm going to add a noise texture. I'll set the size to 360 and use Node Wrangler to set the mapping to object. Now I'll add another color ramp and set the left stop to 0.4 and the right to 0.9. Once I plug the noise into the ramp, I can then plug that into the B input of the subtract color node I made earlier. Now that the curvature is set up, I want to remove the concave areas since edge wear only happens on the outer corners. This is where my ambient occlusion bake comes in, so I'll add an image node and select my AO bake. Next I'll add a ramp for the AO and set the left color stop to 0.7 and the right to 0.8. I want to invert that ramped AO bake, so I'll add an invert color node and plug the ramp into the color input. Now I'll duplicate the subtract color node we made earlier and plug the inverted AO ramp into the B input. Next I'll plug the noisy curvature map I made into the A input. Now if I preview the curvature map, you'll see the outer corners have a clean outline where the edge wear would appear. We're not done yet because I want to bake this to a map so I can use it to add edge wear to the low poly model. So in the curvature material, I'll add a new image, name it, set it to 4K and switch it to non-color. This will be the image we bake the curvature map to. Now I'll plug the curvature nodes I made earlier into the base color of the material so I can bake the diffuse. I'll select the first object mesh, make sure the mask image is still highlighted, then set the bake type to diffuse and turn off selected to active. Now when I click bake, the nodes generating the curvature map that are plugged into the diffuse slot will be baked down. Repeat this for every object you want edge wear on. I went ahead and added the curvature map to the low poly material to give it some subtle edge wear. I hope this helped and gave you a clearer understanding of how curvature maps can fit into a hard surface workflow. If you'd like to support the channel, leave a like and subscribe for more Blender Bitstream. Thanks.